What is t-test? A t-test is a statistical test that is used to compare the means of two groups. It is often used in hypothesis testing to determine whether a process or treatment actually has an effect on the population of interest, or whether two groups are different from one another. Illustration of t-test. Suppose you are interested to determine if the mean petal length of iris flowers differs according to their species. For this, find two different species of irises growing in a garden and measure 25 petals of each species. You can test the difference between these two groups using a t-test and null and alternative hypotheses. The null hypothesis, H sub 0, is that the true difference between these group means is 0. The alternate hypothesis, H sub A, is that the true difference is different from 0. When to use a t-test? A t-test can only be used when comparing the means of two groups, aka pairwise comparison. If you want to compare more than two groups, or if you want to do multiple pairwise comparisons, use an ANOVA test or a post hoc test. The t-test is a parametric test of difference, meaning that it makes the same assumptions about your data as other parametric tests. The t-test assumes your data are independent, are, approximately, normally distributed, have a similar amount of variance within each group being compared, aka homogeneity of variance. If your data do not fit these assumptions, you can try non-parametric alternative to the t-test, such as the Wilcoxon signed rank test for data with unequal variances. What type of t-test should be used? When choosing a t-test, you will need to consider two things: whether the groups being compared come from a single population or two different populations, and whether you want to test the difference in a specific direction. Paired samples t-test. Investigate whether there's a difference within a group between 2 points in time. If the groups come from a single population, example measuring before and after an experimental treatment, perform a paired t-test. This is a within subjects design. Independent samples t-test. Investigate whether there's a difference between two groups. If the groups come from two different populations, example two different species, or people from two separate cities, perform a two-sample t-test, aka independent t-test. This is a between subjects design. One-sample t-test. Investigate whether there is a difference between a group and a standard value or whether a subgroup belongs to a population. If there is one group being compared against a standard value, example comparing the test scores to a given mean, perform a one-sample t-test. One-tailed or two-tailed t-test. If you only care whether the two populations are different from one another, perform a two-tailed t-test. If you want to know whether one population mean is greater than or less than the other, perform a one-tailed t-test. What is a two-tailed test? A two-tailed test, in statistics, is a method in which the critical area of a distribution is two-sided and tests whether a sample is greater than or less than a certain range of values. It is used in null hypothesis testing and testing for statistical significance. What is a one-tailed test? A one-tailed test is a statistical test in which the critical area of a distribution is one-sided so that it is either greater than or less than a certain value, but not both. If the sample being tested falls into the one-sided critical area, the alternative hypothesis will be accepted instead of the null hypothesis. Performing a t-test. The t-test estimates the true difference between two group means using the ratio of the difference in group means over the pooled standard error of both groups. You can calculate it manually using a formula, or use statistical analysis software. T-test formula. The formula for the two-sample t-test, aka the student's t-test, is shown below. In the formula, t is the t-value, x sub 1 and x sub 2 are the means of the two groups being compared, s squared is the pooled standard error of the two groups, and n sub 1 and n sub 2 are the number of observations in each of the groups. A larger t-value shows that the difference between group means is greater than the pooled standard error, indicating a more significant difference between the groups. The output provides an explanation of what is being compared, called data in the output table. The t-value, minus 33.719. Note that it's negative, this is fine. In most cases, we only care about the absolute value of the difference, or the distance from zero. It doesn't matter which direction. The degrees of freedom, 30.196. Degrees of freedom is related to your sample size, and shows how many free data points are available in your test for making comparisons. The greater the degrees of freedom, the better your statistical test will work. The p-value, 2.2 times 10 to the power of negative 16th, that is, 2.2 with 15 zeros in front. This describes the probability that you would see a t-value as large as this one by chance. A statement of the alternative hypothesis, H sub A. In this test, the H sub A is that the difference is not zero. The 95% confidence interval. This is the range of numbers within which the true difference in means will be 95% of the time. This can be changed from 95% if you want a larger or smaller interval, but 95% is very commonly used. The mean petal length for each group. From the output table, we can see that the difference in means for our sample data is negative 4.084 as a result of 1.456 minus 5.540, and the confidence interval shows that the true difference in means is between negative 3.836 and negative 4.331. So, 95% of the time, the true difference in means will be different from zero. Our p-value of 2.2e16 is much smaller than 0.05, so we can reject the null hypothesis of no difference and say with a high degree of confidence that the true difference in means is not equal to zero. Presenting the results of a t-test. When reporting your t-test results, the most important values to include are the t-value, the p-value, and the degrees of freedom for the test. These will communicate to your audience whether the difference between the two groups is statistically significant, aka that it is unlikely to have happened by chance. Summary statistics for the groups being compared can be also included, like mean and standard deviation. In the given example, the APA report should be like this. The difference in petal length between Iris species 1, M equals 1.46, SD equals 0.206, and Iris species 2, M equals 5.54, SD equals 0.569, was significant. T of 30 equals negative 33.7190, P 2.2 times 10 to the power of negative 16th. Reference: Bevans, R. 2023, June 22.